All righty. So welcome to Math 30-2, our first kind of informational session, and then we'll go on into a bit of Module 1. I had an excellent question about formulas. Okay. Now, whoops, and I apologize right up front. My penmanship is not great. I have to write on my whiteboard. I don't have a horizontal surface to write on, so my penmanship is not the best. You are provided with the government formula sheet. Everyone should be able to go on. It's underneath the startup info section and print out the government formula sheet. Now, however, I highly agree that every single module, there's lots of other little things that come up that are not on that formula sheet. Now, I'm a little bound by the rules of this course from the top down, from the government. So I can't allow anything but that formula sheet to come in. But I have a suggestion for you. What I would do as a student is I would get probably like a nice colored piece of paper, something that kind of, was easy to find in your binder. And every time I came to a formula, a symbol, something that wasn't on the formula sheet, I'd make my own formula sheet. Now, having said that, you're not going to have tons in every module. You're going to have like 4 or 5 things. And then before you sit down to take one of my module tests, study that up, put it away, set down, your coordinate will get you all ready, get a piece of paper and frantically write them down. Okay. Nothing says you can't have it up here, right? I just am bound by the fact you're not allowed to carry it in. So I suggest making your own, student formula sheet slash, if we don't want to call it a formula sheet, I guess formula sheet's just as good as anything. Put all the things on there that are not up on the government formula sheet. And I think that's one of the things that we'll do today is talk about some of the things that aren't on that formula sheet that you would want to have kind of, within your grasp. Okay. So I'm going to pull up the formula sheet on my other screen here. And I use that as a bit of a start for where we want to put some of our things. So, where is it? Okay, so if I look away, I'm just looking on my other screen here, so I have more room. So in terms of the set notation stuff, it's underneath logical reasoning, and there's a little bit there. Just a little bit there. So I'm going to write down what's there just so I have it on my screen, and then we're going to fill out all the other symbols that are not there. Okay, so on the actual given formula sheet, it's on the bottom right, interestingly enough, because I think most teachers start with this section, but nonetheless, they don't have to. Underneath logical reasoning. And the ones that are there are A with a dash. Now, just having this said to us what it is might not help at all. So once I get this, complement, they don't say complementary, complement. Once I get this down, we probably should flush out that we know what they mean before we add to it. This one's kind of self-explanatory, the empty set. Basically means nothing in there. And then we've got the intersection. And we've got subset. And we've got union. Okay, let's talk about the ones that are on the actual government formula sheet. Make sure we understand what each of them are saying. And then see if there's some that we haven't added in. I'm trying to think in my little brain as to what other things might come up. The complement. It's not that I say, oh, you look very lovely today. I'm not giving you a compliment. That's not what that means. And it's kind of an odd word, I would have to say. But if we wanted to kind of show a picture of a compliment, say that I had something where the two circles, say it looked like this. And say this was A in here in that circle. The indication of A with a dash, a not. If you're listening to any videos online and they say the word not, that's how they say they, not A, so A not. A naught is everything out here. So this part, including what's in this guy. So in other words, everything that's not in A. Okay, that's what A naught is, or not A. It's kind of a weird way, kind of almost speaking backwards. The empty set is basically when you have no items in the answer. I tell you what, I hardly ever use the word empty set or the symbol empty set. For whatever reason, it's not one that I use very often. Intersection, if I draw another nice little set with things overlapping like this, the intersection is this piece right here in both, okay? The word intersection, think of it as the word both. And it's this little piece right there, okay? Now I'm going to jump over subset because it makes more sense to me to talk about union with you guys and then talk about subset with you guys. So if I do another picture here, like this, and then we talk about union, the word union, a good word is or, okay, to think about it. And if I highlight union, it would be this part. And maybe it'd be best if I had A, B. So this would be A union B. If I want to go back up here and have A's and B's, this would be A intersection B. Okay. And then subset I'll do out over on the left-hand side. Let's do this guy over here. Now let's say that again, we have a picture. This one comes up on the assignment. There's something similar. So let's say I draw a circle. Say I have another circle over here that's not touching. And then I have a circle within a circle. That guy is a subset. So if again, I can label things A and B, and let's say I call this P. P is a subset of A because it's all directly inside. Okay, now I'm going to quickly just refer to the textbook, see if I've forgotten any. As I say, this is the only course in high school they do all these symbols. I just don't want to miss any. No, I don't really think we've missed too many. Trying to think. Universal set, subset, complement set, empty set. Oh, disjoint. Do you guys know what the word disjoint means? Okay, so why don't we, it's not really there's not really a symbol for it particularly. Disjoint and empty set sort of kind of go together. Who wants to tell me what disjoint means? Any ideas? Let's just move over here. So this might be something that you'd put on your own formula sheet now, because we're off of their formula sheet. So let's see if my pen doesn't want to work. Okay, go ahead and tell me what disjoint means.
So a disjointed set is a set that has no relation to another. So for example, it would be, what are your favorite fruits and what are your favorite vegetables, right? You're not going to have a crossover because they're two different things.
Good.
Another way to put it is mutually exclusive, right?
Oh, look at him. We hadn't got that far. Very good. So two sets with no items in common.
Yep.
And another idea that's further along in the unit, that's in this unit, right? Mutually exclusive, because I know we got a whole bunch of, so they are mutually exclusive.
That's module 2.
Yeah. So, okay, we'll just write that in there, but we'll put in there that we do talk about this more in module 2. So for module 1, what you need to know, again, if we do a picture, is that if we had A here and B here, those would be disjoint sets. A and B would disjoint. There's nothing in common between the two of them. Okay, so that would be an example of disjoint. Now let's just see if there's any other terminology that I need to go over before I just go and kind of blast off into some examples. Don't don't see anything right now. If something else comes up in my mind, then obviously we'll write it down. Now, what I think would be a great thing to do is why don't I highlight some of the questions that I know students really struggle with, because I've taught this for a long time. And on my assignments, there's a few questions that I know in general students kind of really have a tough time engaging in. Let's talk about set notation and how to write set notation and get it all written correctly. So let's do a little bit of this. Now, if you've looked at the assignment, you'll know kind of what I'm talking about here. Okay, so let's say we're given a question that looks like this: x such that x is greater than or equal to 1. X is a real number. No, let's do integers instead. Real number would be a pain in the neck. Okay, so say we're given that, and what we're asked to do is number one, list the elements. Number two, write it in words. And number three, maybe write it in interval notation. Okay, so I'm going to stop talking for a second. You guys give that a little go, and then we'll talk about it. Okay, so in terms of listing the elements, this becomes a little tough because I made something greater than or equal to 1, but this is what the expectation would be. You would just start with 1 because 1 is included, 2, 3, 4, and then go dot, 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 indicating it goes on forever. Okay, write in words. Okay, so what we would say here, we have to pick up on the fact that these are integers. So we would say all integers greater than or equal to 1. Now, interval notation, I don't know that it comes up a ton in module 1, but it's something we should know long term. So I thought I'd throw it in here. Interval notation is a much easier way of writing sets, as long as nothing wacky's going on in them. So in this one, we use a closed bracket to indicate that we're starting at the number 1 because number 1 is included. We use a closed bracket if the number is included. And then a comma, and then the highest number. Well, this goes on forever, so we go to infinity. And we use a closed round bracket here because infinity is not really a number. It's kind of an idea. You go forever. So when it's not included, we use a round bracket. Now, I will say that that's not really part of module 1 particularly, but it is part of something that you should have hopefully come with a bit of knowledge from 20-2. If you've come from maybe 20-1 or something, we don't do it as much there. So, but it is something that we should know. Now, what about maybe a little wackier one than that? So let's say we have something like y equals 3x. 1 is less than or equal to x is less than or equal to 5. X is an integer. Say we're doing the same thing. So we want to list the elements, write in words, and we can't do this one in interval notation because it's not a normal one. So we'd only be able to list and then do words. So try that and see. I'll give you a little second. My phone's being very loud, so I apologize about that. Do you guys know what this is saying to do for us? Because see, we've got 2 letters. We've got a Y and we've got an X. It's a little bit different. So what this is saying is we're going to put the number 1 into our little expression. We're going to take this little expression y equals 3x. And we're going to put 1 in. So we're going to get 3 times 1 is 3. And then we're going to have our second term is 3 times 2 is 6, so on, up until we put a 5 in. So our terms, if we list them, there they are, 3, 6, 9, 12, and 15. So that's how we would list them. That's how we'd show it. In words, we want to be a little cagey about it. We could say the numbers 3, 6, 9, 12, 15. We're a little bit more sophisticated than that in this class. We would want to say the multiples of 3 from 3 to 15. That would be the words that they would want you to write. The multiples of 3 from 3 to 15. Okay, any questions? So that's a little section that I find not even as hard going from set notation to the numbers. I find more trouble going from the numbers to set notation. So I thought I would throw one more at you guys to see if you guys could write it in set notation from the numbers. Go ahead, got a question.
When doing set notation and setting parameters like this, wouldn't it be y is such that y equals 3x and x is greater than or equal to 1 and less than or equal to 5 and is an element of the integers? If we were to properly like write it out
yeah, you know what, you're probably right. Yeah, you're being very particular, but particular is great. We probably should write that at the front. So, and now we always do that when we have one letter. I guess we really should. Now, you also said one other thing that I'd like to kind of flush out, because that's a really great question. Let's look at this for a second. When something is written that way, so I'm just going to kind of move over here and continue talking about this set notation, because it is kind of the tricky, they're tricky. So if I want to, let's say I just have something like this written like this, out of context from what we were just working, we can say that this terminology here is really how we mathematically write between. You might find that really helpful. So if you're trying to indicate to the reader, me or someone, that it's the numbers starting somewhere and ending somewhere, this is how we write it. Really what's happened is we've taken the way we would get there, say that we're reading something, is if say we had x is greater than or equal to 1 and x is less than or equal to 5, say that that was what we had, because that is what we have, but we don't write it that way. The way we combine it is we change the sides of this. So we write 1 over here and x over here. We change the symbol around, and then we slot this in here like this. And then we just only write the x once. See how that happens? Sometimes I have students that go, why is it a less than sign? Well, that's how it gets to be a less than sign. The thing for you in your class to remember is that this terminology means between. Okay.